As our project has already been selected in the IIT Bombay Tech Fest and the event art, so we are up with our new video presentation on wireless transmission of electricity, that is Witricity. So let me first tell you about the workbench of ours. I will let you know about the designation of each and every part. This is a cathode ray oscilloscope. This is a programmable power meter. This is a AC-DC power supply, and this being the function generator.
Yes.
Now, as already mentioned in our previous video, that we are working upon the concept of resonance, that is maximum flux linkage concept, which is Faraday's law of induction. So the flux is being linked from the primary coil to the secondary coil. So this is basically a function generator whose supply is being given to the primary coil, and the resultant flux is being introduced into the secondary coil. As according to the requirement of the event, it was desired to get a proper efficiency. That means we had to work upon increment on efficiency. So we have definitely increased the efficiency from our previous videos to the current one to a very great extent. So let me show you up the distance to what extent we have increased the efficiency. Now I urge my friend Darshan to just help me out in showing you the distance. So as with the help of an inch tape, I can show you that the LED is being blown up to a distance of 55 centimeter nearly. So you can see that this distance is 55 centimeter, and please Akash, just let them show the LED glow. So fine. So we have the axial bulb glow. In our previous video, the axial glow was nearly of 5 centimeter, which has now been increased up to 55 centimeter. That means our efficiency has increased nearly to up to 11 times. So the resonating frequency which we have been using is of the value of 19.5 kilohertz. We are also having an increment in the radial efficiency, and the rest of the presentation will be continued by my colleague Vivek.
It's Vivek Sharma. As explained by my colleague Mr. Abhinav Singh, that we have to increase the efficiency. Now he has shown that he has improved the efficiency axially. Now what we are trying to do, we are trying to improve the efficiency radially. Now you could see that here is the distance, there is the axial glow. When the secondary coil has been kept axially, there is a glow. Now what we are doing, we are increasing the distance. You could see that there is still, the LED is still glowing. Now we keep on increasing the distance, and we could see that the LED is still glowing. We could move it anywhere, and the LED is still glowing. Now we measure the distance from center to center, and we could see that the axial distance comes out to be about 45 centimeter, which earlier was 15 centimeter. So we could see that we have increased the efficiency up to 3 times. Earlier video it was 15 centimeter, and now it is 45 centimeter, my dear friend. Now what we have done is, we have actually increased the flux linkage of the primary with the secondary. So there are the two methods for increasing the flux linkage. Either we increase the number of turns, or we increase the current in the primary coil. But as we were short of the equipment, of having such a high current with high frequency, so we have better increase the number of turns on both primary and secondary. Here in the secondary coil, what we have done is, we would like to see here in the secondary turn, what we have done is, we have increased the number of turns and also increased the area, so that there would be the step up voltage, so that the voltage could step up here. You could see here that the secondary number of turns in the secondary voltage is 40, and the number of the turns in primary voltage is 30. So the number of the turns, and earlier video, it was number of the turns in the primary was 14, and in the secondary was 20. So we have increased the area in the secondary coil, and also increased the number of the turns in the secondary coil, so that the voltage could step up. So in this way, we are able to achieve a maximum radial glow with this system. Now I'd like to invite my colleague Mr. Darshan Maheshwari for the other features of this system.
Good evening, this is Darshan. I will explain you that even at different functions the LED will glow appreciably, but still we have to change the distance between the primary and the secondary. Now I request Akash to have a close look up at the function generator. This is the square wave and it is operating at 19.52 kilohertz. The LED is glowing. Now if I will change the function from square to DC, at DC there is no glow in the LED since there is no induction in the secondary coil. When the function is signed, the LED is still glowing, but the maximum distance between the at the radially, the maximum distance between the two coils will decrease. This is from the fact that since in the square wave there is a sudden decrease in the voltage, since the voltage decreases suddenly to 0, but its sine wave and the tri wave it is not so. So when we use the square function, the EMF generated is quite high. So I will show you even at the tri function the LED is still going. This is the tri function and you can see that the LED is still glowing. Now I would like to explain the concept of resonating frequency. Here the frequency is 19.48 kilohertz. Now if I will change the frequency a bit, I've changed the frequency to 18.32 kilohertz, but the LED is not going in this situation. If I will increase the frequency a bit from my initial frequency, say to 20.5 kilohertz, still the LED is not glowing. So this clears the concept of resonance, that the resonating frequency is unique and at that particular frequency the LED will glow. Now I would like to explain that even the magnetic field can pass through even the obstacles. If I will move the primary coil beneath the bench, still the LED is glowing. This explains that the magnetic field can also penetrate through the wooden block or any kind of obstacle, and this will also work in the mutual induction. This is all what we are supposed to explain in the last video. Thank you.
And I am here to give you our practical utility of our Witricity system. Now, as you can see, this is our secondary coil number 1 and this is secondary coil number 2 and this is our primary coil. Here we can see that from the same primary source we can lighten up two secondary coils simultaneously. Like you can see, this is our secondary number 1 which is lightened up by our primary, and this is our secondary number 2. Here we can see that two secondaries are lightened up with the same primary source. So the funda of conservation of energy comes here. We can use single primary source for more than one secondary. Here we have to supply power to only one source and we can utilize it by many number of secondaries. Thank you.